Hey there, fellow soil enthusiast. If you've been following along here at Grow with Soil, you know we're always chasing that one thing every gardener dreams about: rich living soil that makes our plants absolutely thrive. Today, we're diving into a question that's been popping up more and more in the gardening world. Should you be fermenting your kitchen scraps and garden waste, or sticking with good old-fashioned composting? I've spent the last 2 growing seasons testing both methods side by side, and what I discovered about nutrient delivery might surprise you. Let's get real for a moment. Both composting and fermenting have their passionate advocates, and honestly, both methods have merit. But when it comes to delivering bioavailable nutrients directly to your soil in a form your plants can actually use right now, there's a clear winner, and it's the method that's been around for thousands of years: traditional composting. Now, before the fermentation fans close this tab, hear me out. I'm not saying fermentation doesn't have its place in the garden. What I am saying is that when we look at the science of nutrient availability and soil biology, composting creates something fermentation simply cannot replicate, and that's what we're going to explore together. Here's what changed my perspective completely. I sent samples of both my fermented bokashi and my finished compost to a soil testing lab, and, wow, the results were eye-opening. The compost didn't just contain nutrients, it contained nutrients in forms that soil microbes and plant roots could immediately interact with. The fermented material, while rich in certain compounds, required additional breakdown time in the soil before plants could access most of its nutritional value. Composting works through aerobic decomposition, meaning oxygen-loving microorganisms break down organic matter into humus, that dark, crumbly, sweet-smelling gold we all love. During this process, complex organic compounds are transformed into simpler forms. Nitrogen becomes available as nitrates and ammonium. Phosphorus is released from organic bonds. Potassium, calcium, magnesium, and trace minerals all become plant-available. But here's the kicker. This process also creates stable organic matter that improves soil structure, water retention, and provides long-term fertility. When I dug into the science deeper, I learned that finished compost contains between 10 million and 1 billion beneficial bacteria per gram. These aren't just passive nutrients, they're active participants in your soil food web. They continue breaking down organic matter, competing with pathogens, and creating nutrients on demand for your plants throughout the growing season. Fermentation, particularly through methods like bokashi, uses anaerobic processes where specialized microorganisms break down organic matter without oxygen. The result is a pickled, acidic material that's technically pre-decomposed. So, I've used bokashi for years, and honestly, I genuinely appreciate its ability to handle things like meat, dairy, and oils, stuff that really shouldn't go in a regular compost pile. But here's what I noticed in my own garden trials. When I buried fresh bokashi in my vegetable beds, it took another 4 to 6 weeks before I saw real plant growth improvements in that area. The material just needed some time to neutralize and continue breaking down in the soil. My plants sometimes showed signs of stress if I planted too close to freshly buried fermented material because of its acidity and, the continued decomposition process happening underground. Compare that to finished compost, which I could immediately mix into planting holes or use as a top dressing with instant benefits. The difference in my tomato trials was really stark. The plants grown in beds amended with mature compost consistently outperformed those in beds where I'd buried fermented material just weeks before planting. What really sold me on composting's superiority for nutrient delivery was understanding the soil food web. Your soil isn't just a medium for holding plants upright, it's actually a complex ecosystem. Finished compost introduces beneficial fungi, bacteria, protozoa, and nematodes that create a living network around plant roots. This network doesn't just deliver nutrients, it also protects plants from disease, improves soil structure, and even helps plants communicate stress signals. So, I started using a microscope to examine my compost and soil, and honestly, watching the diversity of life in finished compost compared to fermented material was like, Well, comparing a thriving city to a quiet town. The fermented material had its specialized microbes, sure, but the compost was just teeming with diverse life forms at every stage of the soil food web. When you add compost to your soil, you're not just adding nutrients, you're adding the workers that will continue mining and delivering nutrients from the soil and organic matter all season long. That's something fermented material alone cannot provide in the same way. If you're convinced that composting is the way to go for real nutrient delivery, let me share what's worked incredibly well for me. The key is creating conditions that maximize nutrient retention while promoting complete decomposition. First, I maintain my pile with a carbon-to-nitrogen ratio somewhere between 25:1 and 30:1. This means roughly 3 parts brown materials like dried leaves and cardboard to 1 part green materials like kitchen scraps and grass clippings. This ratio keeps the pile hot enough to break down materials quickly while retaining nitrogen instead of losing it to the atmosphere. So, I turn my pile every 5 to 7 days during active decomposition. This introduces oxygen, prevents those pesky anaerobic pockets that can create nutrient-robbing conditions, and honestly, it speeds up the process dramatically. My hot compost is typically ready in about 8 to 12 weeks, compared to the 6 months to a year that passive piles require. That's a pretty big difference. Moisture management is crucial too. I keep my pile as damp as a wrung-out sponge. Too dry and decomposition slows to a crawl. Too wet and you'll create anaerobic conditions that lose nitrogen and, well, create that awful ammonia smell. I check moisture by squeezing a handful. If a few drops come out, it's perfect. After 2 years of side-by-side comparisons, soil tests, and honest observation, I can tell you that composting delivers superior nutrient availability for immediate plant use. It creates a living amendment that continues feeding your plants long after application, improves soil structure in ways fermentation cannot match, and builds the biological foundation for truly healthy soil. Does this mean you should abandon fermentation entirely? Not necessarily. I still use bokashi for food scraps that can't go in my compost, but now I treat it as a pre-processing step. I bury the fermented material in areas I won't plant for at least a month, or better yet, I add it to my active compost pile where it gets fully processed into that nutrient-rich humus we're after. Your soil deserves the best, and based on everything I've learned and tested, composting is the champion for delivering real bioavailable nutrients that transform good gardens into extraordinary ones. Start composting today and I promise you'll see the difference in your soil and your harvests. If this deep dive into composting versus fermenting helped you make better decisions for your garden, do me a favor and subscribe to Grow with Soil. Share this with your gardening friends who are still on the fence about which method works best. Together we're building better soil, one garden at a time. Now get out there and make some compost magic happen.